of presentation is Chapel, a parallel programming language. So the topics covered here are an introduction to Chapel, motivating ideas for developing this language, then a small comparison of Chapel with some familiar languages like C and Java, which will help to grab the basic idea of language more easily. Then some basics of Chapel, like the syntaxes and types that are used in the language. Then components that help parallelism in Chapel. Then concluding with a summary and the future directions that are planned for this new language. So Chapel is an emerging parallel programming language and is developed at Cray. Chapel is designed from the scratch rather than by extending some existing languages. And the main goals of the language is to attain high productivity with parallelism, as much as possible, right, with the parallelism. And for allowing the programmers to implement parallelism to their program very easily, for making parallelism really easily accessible for the programmers. So those are the main goals of the language. Now to the motivating ideas. So these are the ideas that are followed while the development of the language, like general parallelism, multi-threaded programming and execution model, multi-resolution design, locality control, establish role for users versus compilers. Let's see one by one. General parallelism means it should allow to implement different types of computation styles like data parallelism or task parallelism or synchronization based concurrent programming, anything like that. Then multi-threaded programming model, that is, the users are allowed to express parallelism by their task, which are later on taken by the threads to subtask them as required. Okay. Next is multi-resolution designs, means user can enjoy both the high-level abstractions and at the same time they can do low-level programming also. So they can work at different tiles in the same language, right? Then it is locality control. That means to help control where the data values are stored, either in the cache or in the shared memory, like that. Then establish a role for users versus compilers. That is, this gives the user should have more power. Like the user should be given the opportunity to identify parallelism and to manage locality of data, rather than depending wholly on the compilers. Right? So these are the motivation ideas followed while developing the Chapel language. Then some syntaxes. Simple syntaxes that are used in the Chapel language are statements separated by semicolons. Okay? Then compound statements should be separated by curly brackets. They all seem very similar, very familiar, right? Because they resemble the famous language C. Okay? That's really good. In addition to that, to enhance readability and productivity, Chapel introduced modular left-to-right keyword-based approach. Let's see that with an example here, like variable, yes, boolean, true, right? That means there is a variable s, it is of type boolean, and it's of value true. That's left to right. This makes readability very easier, right? So that's the modular left to right approach used in Chapel. So var, where is the keyword used. Then another type of keyword is type, which is type C-type complex. Here means C-type is an alias for the complex type. Then another keyword is proc, that is for introducing a new procedure in the language. And some other keywords that are used in the language are param, that is to create compile time constants. Then const for runtime constants. Iter for creating iterators that can be used in loops and arrays. Then module, that's for modules for namespace management. So now record type and class type. These are very similar to structs in C++ and class type in Java. That is, record type is similar to structs in CPP. That is, record type supports value semantics, while the class type supports reference semantics. That is, they are just like the Java class objects which are used to reference classes. Okay, so record type and class type in Chapel. So now to the basics of Chapel. Let's start with a hello world. Hello world, the ways to start any new language, right? It will help us to feel the language, to start with it. So let's also do the same. Write a hello Cray block. So for compiling it, Chapel hello.chapel -o hello. This is the object file, right? So /hello means hello create block. That's the output. Just as simple as that, right? So to the next level, we can see the program begins with creating a module hello, then a constant variable message is declared here, which is initialized to hello create block, right? This is the default value for the variable. Then there is the procedure main. This is the entry point to the program, procedure main, and write ln message. So the variable is used here. So while compiling it, if we are just running the program like /hello, we will get the output like earlier, hello create block. That's the default value of the variable will be displayed. Also, we can override the value of the message during the runtime itself. That is like /hello -message, the variable name, right? So, and we are giving a new value for this variable HiMom. So now the output is going to be HiMom instead of the default value, right? We are overriding it. Now it's a type tuple that is used in Chapel. So tuple is usually used to bundle up different types of values in a variable. For example, we can see a variable t is here and it's going to have an integer value and a real value. So here the initialization we can see there's 1 is an integer and 2.t a real, right? So the tuple is helping to bundling up, putting together different types of value into a single variable. Okay, that's going to be really useful, right? Okay, that's tuple in Chapel. Next is range. Range, just like the name itself, range is used to represent a sequence of integer values, like which are used in control loops and arrays, like 1 to 9. That means 1, 2, 3 to 9. 1 to 9 by 2 means it's the odd numbers 1, 3, 5, 7, 9. 1 to 9 by -1 means the reverse order, like the 9, 8, 7 to 1. 1 to 9 by 3 means 1 to 3, the first 3 numbers in the series. The 1 to 9 by -3 means just the same but the reverse, like 7, 8, 9. The 1 to 9, 6 by 2 means starts from 6 but by 2, that is 6 and 8. So range is here helpful, like in arrays we can see. We use the same Java and C, like for I equals 0, I less than 10, I plus plus, or I equals I plus 2. So those control over the iterations is made here in Chapel with the help of range. That's range in Chapel, okay? The next is arrays. So Chapel provides an extensive support for different types of arrays, like one-dimensional arrays, two-dimensional arrays, and the new one introduced in Chapel is triangular skyline array. Here there are two arrays, one inner array and an outer array. So the inner array tri here is having its elements, each of its element as a one-dimensional array, and its length is going to be equal to the index in the outer array. So that's a triangular skyline array with an inner array and an outer array. Okay? So arrays in Chapel. And the next is type inference. This is a really very useful and interesting type used in Chapel. It makes type specification tasks very flexible. That is, with an example we will see how. So here there is a variable count and we are not mentioning what type it is, right? So instead we are just initializing a value to the variable. So here C is an integer. Now this integer type is going to be inferred for count also. So now variable count is going to be of type integer. Okay? So the different example, parameter pi equals 3.14. So now pi is also going to be a real type, right? So now the useful part is variable length we are declaring here, right, without any type. So, but what happens is we are making a call to compute length. So what happened here is like whatever value this compute length returns, the type of that will be inferred to this variable length. So whenever we create a program, we will find this problem, right? Mismatch problems, calling a function and the returning value and the variable to which the value is stored should be matching, right? So the function call is going to be made very usable with this type inference, right? This is going to be really interesting. Very good. Okay, that's type inference in Chapel. The next thing is, what are the task parallelism components that are used in Chapel? Like for all, co-for all, begin, co-begin, sync, reduce. These are going to help with creating threads, controlling threads, like working with threads, like that. So let's see one by one. So for all is the for loop that is used in Chapel. And here, a thread is created for each core in the system. So let's see with an example. So variable sum is here, which is an integer and is initialized to a value 0. So for the loop I in 1, a variable sum is there and is going to be summed up with all the values of I. And also we can see there's a race condition y, because this variable sum is going to be accessed by more than one thread that is created in this for loop, right? So that will result in the race condition. So what we are going to do to handle the race condition that will happen in this for loop, for that we use a variable called sync variable. If you remember the Schwartz algorithm we referred to in this course, we have seen a sync variable node value. Just like that, the sync variable is going to have two states, empty and full. That means when a sync variable holds a value, it is said to be in the full state and it won't allow any other thread to access it and to assign some other value. In order for the sync variable to be used again, the values in the sync need to be transferred to some other value. In that way, it will move back to its empty state. So just like the matters, right? That is, when a matter is full, we can't use it for any purpose, right? Once it is emptied, we can use it again, just like that. So this code we can see now, it's like variable total sync variable we are declaring, right? S by n with the keyword S by n and the for loop. This is just like total plus equals I, just like the previous code, but the only difference is now it's a sync variable, so no more than one thread can access it at the same time. So next is for all. So it is just like for all, except that a thread is generated for each iteration. So instead of for each core, here for each iteration a thread is generated. So whenever each iteration is going to be a really big operation, it's going to consume a really good time, this for all is going to be very helpful. The next is begin. Begin is like a flag, like it says to start a new thread. Like here in the statement we can see begin right element. That means start a new thread for this task. So once the statement is doing, the next one we see is begin, and again one more thread will be generated like that. So begin is a flag for starting a new thread. Co-begin is also just like that. It flags for starting a new thread, but with priority. That means all the tasks in here needs to be completed before the main flow goes to this statement. Okay, so in the previous slide we can see when the control sees that a begin is here, a thread will be started and the main flow will be going to this statement. But in the case of co-begin, it's like when it sees a co-begin, all the tasks and flows within that co-begin statement need to be completed before the main flow goes to the next statement. So it is setting a priority or order in which the thread needs to be executed. That's co-begin. The next is reduce. So for every parallel task, we can see that towards the end we need to combine all the resources produced from all the threads, right? So reduce is a type that helps in putting all the results together. For example, variable sum equals plus reduce A. That means all the values in this array A will be summed up and put in the variable sum. So reduce, combine the results. It helps to combine the results. Reduce is a feature that eases the combining the results from the threads. Okay? And now, if you're planning to do any future project or program in Chapel, this is a very quick reference document that is available from the Cray website itself. Like here, they are having all the types and syntax all available in a single document itself, and this will be really helpful. So I am keeping a link for this here so that you can use it. And I'm summarizing it, like Chapel is designed for enhancing programmer productivity and it is in its improving phase. And at that point I would like to add some future directions here, like logical task team. They are trying to plan like ability for one task, ability for grouping so many tasks together so that the tasks can communicate with each other, then handling error condition in large scale codes, then improvement for parallel executor framework, then support for hierarchical local models, support for partial reductions and support multiple algorithms. So these are the future directions they are planned for this new language, and this is going to be a good parallel programming language for sure with this with these ideas and concepts. So that's it. These are the references that I used. Thank you. Thanks for watching my presentation.